Here is a question that sounds stupidly simple until you actually think about it. Why do humans cook? Every other animal on Earth eats its food raw. Lions don't marinate their kills. Gorillas don't roast their fruit. Dolphins have never once assembled anything that could fairly be called a meal. And yet, every single human culture ever discovered, everyone, without exception, across every continent, every climate, every level of technological development, from the most isolated hunter-gatherer communities to modern industrial societies, cooks its food. It is the one genuinely universal human behavior, not language, which varies enormously in structure and form, not tool use, which other animals also practice in varying degrees, not music or religion or trade. Cooking. Heat deliberately applied to food before eating. Only humans do it, and all humans do it. And we have been doing it for so long that we have become, in a very real biological sense, dependent on it in a way that no other species is dependent on any technology. That last part is the thing most people don't realize, and it's the part that makes this story genuinely fascinating rather than just historically interesting. You don't just cook food because it tastes better, although it does taste better, dramatically so, and we'll get to why. You cook it because you arguably can't survive without doing it. Your body has been reshaped over hundreds of thousands of years of evolutionary pressure into a form that is optimized for cooked food. Your jaw is weaker than a chimpanzee's. Your gut is shorter. Your teeth are smaller. Your entire digestive architecture is different from that of our primate relatives, in ways that point unmistakably toward a body built around processed, heated food. These are not design flaws. They are the physical record of an ancestor who made one of the most consequential decisions in the history of life on Earth and then had their entire body reorganized around that decision over the next million years. And the wildest part, we don't fully know how it started. We don't know if the first cooking was deliberate or accidental. We don't know exactly when it began. We don't know whether our ancestors discovered it by watching food fall into a wildfire, or whether they deliberately sought out fire after tasting something that had been charred by a natural blaze, or whether the first experiments were more methodical than that. We don't even know with certainty if the first cooked meal was meat or plants. What we do know is that whatever happened, whenever the first hominid first tasted food that had been heated by fire and recognized it as better, something clicked, something irreversible occurred, and the species was never the same. Let's start with what the world looked like before any of this happened, because understanding the before makes the after genuinely astonishing. About 2 million years ago, the hominid lineage was approaching a fork in the road. Our ancestor Australopithecus, upright walking, increasingly clever, living on the African savanna, was still essentially running the same dietary playbook that chimpanzees run today. Lots of raw fruit. Raw roots which are tough, fibrous, and barely digestible. Raw leaves, bark, shoots, and whatever insects and occasional small animals could be opportunistically obtained. This diet required enormous amounts of chewing time. Modern chimpanzees spend roughly half of all their waking hours just eating, not hunting, not socializing, not doing anything cognitively complex or socially interesting, just chewing, because raw food requires so much mechanical processing before the body can extract anything useful from it. You chew, and chew, and chew, and then you've processed enough of one mouthful to start on another. Your whole day is structured around this basic biological task. Harvard anthropologist Richard Wrangham spent years studying chimpanzees in Uganda, eating the same foods they ate to understand the experience from the inside. His conclusion, which he described with characteristic understatement, was that the food was genuinely terrible, hard, fibrous, bitter, extremely unpleasant to chew for the extended duration required to actually swallow it. He would spend 10 minutes on a single piece of wild fruit and extract essentially nothing enjoyable from the experience. After extensive personal experimentation with the primate raw food diet, he came away convinced of something important. No human being with our comparatively small jaws and short digestive tracts could survive on such a diet. Not just wouldn't want to, biologically could not extract enough calories from raw primate food to sustain a functioning human body over the long term. This observation planted a seed. If humans can't survive on what other primates eat, If our bodies are genuinely anatomically poorly suited to the raw food diet our distant ancestors relied on, then at some point something must have changed. Something must have allowed us to get dramatically more energy from food than our ancestors did on raw diets. Something must have freed us from spending half our lives chewing. Something must have driven the anatomical changes visible in the fossil record that distinguish our genus from those that came before. What was it? The answer Wrangham arrived at, while staring into his fireplace in Cambridge, Massachusetts in 1997, was cooking. Not meat eating, which others had proposed as the great dietary turning point. Not bigger brains leading to better foraging strategies. Cooking, fire applied to food before ingestion. The hypothesis he published in 1999 in the journal Current Anthropology and expanded in his widely read 2009 book Catching Fire is that cooking was not merely a cultural development that accompanied human evolution as a useful side benefit. Cooking was the engine of human evolution. We didn't develop big brains and then, with those brains, eventually figure out cooking. We cooked, or stumbled into cooking, and as a direct biological consequence of that dietary shift, our brains grew. The causal arrow runs in the opposite direction from what most people assume. To understand why, you need to understand what heat actually does to food at a molecular level, because it is far more transformative than most people appreciate, and the details are where the evolutionary logic lives. When you apply heat to a starchy food, a potato, a grain, a yam, a root vegetable, the heat causes the starch granules inside the food to absorb water and swell dramatically, in a process called gelatinization. The tight, crystalline structure of raw starch, which makes it physically difficult for digestive enzymes to access the caloric content locked inside, breaks down into a much more open, swollen, accessible form. Your digestive enzymes can now reach vastly more of the starch and convert it to glucose. A raw potato is barely digestible. The same potato, cooked thoroughly, releases a substantially larger fraction of its caloric content to your gut. You are eating the same object and getting dramatically more energy out of it, simply because it has been heated. Heat does something equally significant to protein. Raw meat contains tough connective tissue, collagen, elastin, and other structural proteins that is genuinely difficult to break down during digestion, even with powerful stomach acid. Heat denatures these proteins, unraveling their complex three-dimensional structures into simpler, extended forms that digestive enzymes can attack far more efficiently. It also ruptures the cell walls of plant food, releasing nutrients that were locked inside cellulose structures your digestive system cannot break through on its own. Cooking also neutralizes many of the natural toxins, anti-nutrients, and pathogens present in raw food, compounds that plants evolved specifically to discourage animals from eating them. Heat destroys these defensive chemicals, making foods accessible that were genuinely dangerous or nutritionally blocked in raw form. Cooking is, in a very real biochemical sense, pre-digestion. You are doing a substantial portion of the chemical work of breaking food down before you even put it in your mouth, using fire as your external stomach, which means your actual digestive system gets a dramatically easier job and has to expend substantially less energy completing the process. The result, significantly more usable calories extracted from the same amount of food, with considerably less metabolic expenditure required to get them. Studies comparing cooked and raw versions of identical meals consistently find that cooked food provides more extractable energy to the body. This isn't a marginal nutritional benefit. This is the difference between thriving and barely surviving in an environment where calories are genuinely scarce, and the competition for them is fierce. And then there's chewing time. Raw food, particularly the tough, fibrous plant material that primates depend on, requires enormous amounts of mechanical chewing before it can be swallowed and processed. Cooked food is dramatically softer. The structural components that made raw food hard to chew, the fibrous cell walls, the tough connective tissue, the dense starch granules, have been broken down by heat before the food reaches the mouth. This reduces chewing time dramatically, transforming eating from a near full-time occupation into something much more occasional. Wrangham's estimate is that pre-cooking hominids may have spent something close to half their waking hours chewing. After cooking became routine, that time was reduced to something much closer to the hour or so that modern humans typically spend on eating daily. That represents a staggering liberation of time, potentially 4 to 5 additional productive hours per day, freed from the simple biological necessity of mechanically processing enough raw food to stay alive. 4 or 5 hours. Every day. For hundreds of thousands of years. Think carefully about what your ancestors could do with that reclaimed time. Hunt more effectively and with better strategy. Make more sophisticated tools. Maintain social bonds within and between groups. Teach skills and knowledge to younger generations. Sleep more. And more safely. Because fire also provided protection from nocturnal predators, allowing our ancestors to sleep on the ground rather than in trees, in more comfortable and more social arrangements. Explore larger territories. Plan for the future rather than spending every available moment on the immediate biological necessity of eating. The campfire was not just a cooking device. It was simultaneously a security perimeter against predators, a warmth source that extended the range of comfortable habitats, a social gathering point that enabled sustained group interaction, and a time-liberating technology whose effects compounded across generations. Now here's the part that should genuinely stop you in your tracks. What happened to the human body in the fossil record around the time cooking is thought to have begun? About 1.8 million years ago, something significant and relatively abrupt happened in the hominid lineage. Homo erectus emerged, and compared to its predecessors Australopithecus and Homo habilis, it looked dramatically different. Bigger brain, which had increased substantially in volume relative to body size. Taller, longer-legged body architecture better suited to sustained running and long-distance travel. And, critically, smaller jaws, smaller teeth, and a significantly shorter digestive tract. The gut reduction deserves particular attention because it is one of the most striking anatomical changes in the entire fossil record of human evolution. In chimpanzees and other primates, the digestive system is enormous relative to body size. A long, expansive apparatus with a large stomach, a lengthy small intestine, and an especially large colon dedicated to slowly fermenting and extracting nutrients from huge quantities of difficult, fibrous, raw plant material. This massive gut is expensive to maintain. It requires a constant, large blood supply. It generates substantial heat. It demands enormous amounts of food simply to keep itself running. But it is necessary for an animal surviving on raw vegetation with low caloric density. In Homo erectus, this apparatus had shrunk substantially. The digestive tract had been streamlined. Less gut overall, with a proportionally smaller colon in particular, the fermenting section most relevant to processing raw fiber. In modern humans, this trend has continued to the point where, as one researcher put it memorably, whereas other primates have guts that weigh roughly 4 times as much as their brains, the human brain actually weighs more than the human gut. This reversal from gut dominant to brain dominant in terms of metabolic investment represents a profound reorganization of biological priorities. Less gut, more brain. And the only way that trade is biologically sustainable is if the food getting into that smaller gut is dramatically more calorie-dense and easily digestible than what came before. In Wrangham's interpretation, the timing aligns precisely with the adoption of cooking. Soft-cooked food requires less powerful jaws and smaller teeth. Natural selection relaxed the pressure to maintain the enormous chewing apparatus that raw food primates require, and teeth and jaws gradually shrank over generations. More digestible, more calorie-dense cooked food means you need substantially less gut to process an adequate daily intake. Natural selection could downsize the digestive system without reducing fitness, and the metabolic energy saved by maintaining less gut tissue was freed for reallocation, and it was reallocated to the most calorie-hungry organ in the body, the brain, which was already expanding rapidly in this period and which in modern humans consumes roughly 20% of the body's total energy budget, consuming about 9 times more energy per unit of tissue than other body parts require. The brain is grotesquely expensive. It is the most metabolically demanding organ in the body relative to its size, and it cannot be maintained adequately without a very high-quality, energy-rich diet. Brazilian neuroscientist Susana Herculano Housel calculated the numbers explicitly. For a gorilla to grow a human-sized brain while subsisting on its current raw food diet, it would need to eat for an additional 2 hours per day, on top of the 8 or 9 hours it already spends feeding. That brings the total to something like 10 or 11 hours of eating daily, which leaves almost no time for anything else and is barely feasible in terms of available daylight hours. The math simply doesn't work for a raw food large-brained primate. The only path to a bigger brain, given these constraints, is making food more efficient. Cooking did that, decisively and irreversibly. The oldest confirmed physical evidence of controlled fire use in an archaeological context comes from Wonderwork Cave in South Africa, where burned bone fragments and ashed plant remains found in the cave's deep interior, far enough from the entrance to rule out natural wildfire, have been dated to approximately 1 million years ago. A separate and remarkable discovery at Gesher Benot Yaakov in northern Israel, published in 2022, identified carefully heated freshwater fish teeth dating to 780,000 years ago, the oldest direct evidence of cooking food specifically, as opposed to fire use more generally. These dates sit in interesting tension with Wrangham's hypothesis. If cooking began with Homo erectus around 1.8 million years ago, there are roughly 800,000 years of missing archaeological evidence to account for. Wrangham's explanation, and it is a plausible one that most archaeologists take seriously, is that fire evidence from small, temporary campfires in open environments simply does not preserve well over geological timescales. The fires of modern hunter-gatherer communities like the Hadza in Tanzania are modest, short-lived affairs that would leave essentially no detectable trace in sediment after 1 million years. Fire evidence preservation strongly favors fires in caves and other protected environments where ash and charred material can accumulate in stable sedimentary layers. We should expect to be missing most of the early record. By around 400,000 years ago, the archaeological evidence for fire use is abundant, widespread, and unambiguous. Ancient hearths, burned animal bones, fire-cracked stones, and earth ovens appear across sites in Europe, Africa, and the Middle East. By the time Neanderthals and early modern Homo sapiens were active, fire and cooking were clearly well-established, culturally transmitted behaviors, practiced routinely, and passed down across generations as foundational survival knowledge. The question of when exactly the practice began remains open. That it began is not seriously in doubt. There's something genuinely strange and slightly unsettling in what the human body has become as a result of this history, and it's worth sitting with fully. Humans cannot survive on raw food. Not in a this would be inconvenient way or a we'd lose some weight way. In a biologically demonstrable, measurably catastrophic way. Contemporary studies of people who choose to eat entirely raw, unprocessed, unheated food as a lifestyle choice, and there are such communities, consistently find that they cannot maintain body weight over time on raw diet alone without modern technological supplements. They use more metabolic energy to process the raw food than the additional nutrients extracted cover. They are running a caloric deficit that worsens over time. Up to 50% of women on strict raw food diets develop amenorrhea, the cessation of menstruation, which is the body's emergency signal that it has insufficient energy to support the metabolic costs of reproduction. The body shuts down fertility before it shuts down anything else. From an evolutionary perspective, a diet that stops half your reproductively capable females from being able to have children is the most fitness-destroying dietary choice imaginable. It is a diet that leads directly to extinction within a generation. The study of raw food enthusiasts thus provides a controlled, modern experiment that validates Wrangham's hypothesis about deep evolutionary history. Our bodies, reshaped by hundreds of thousands of years of cooking, have lost the infrastructure needed to extract adequate nutrition from raw food. The large fermenting colon is gone. The powerful jaw and extensive molar surface area are gone. The slow, patient digestive system capable of wringing nutrition from raw fiber over extended processing time is gone. What replaced them, the shorter, more efficient gut, the smaller jaw, the bigger brain, only works as a viable biological package if the food coming in has already been pre-processed by heat. Chimpanzees can survive on raw food because their bodies are built for it from the ground up. Enormous guts, powerful jaws, teeth designed for sustained mechanical processing, metabolic rates calibrated for slow, inefficient extraction from raw material. Humans are built for cooked food. Our bodies crossed a threshold somewhere between 1 and 2 million years ago from which there was no evolutionary return. The body adapted incrementally to cooked input, shed the infrastructure it no longer needed, redirected that metabolic investment to the brain, and became irreversibly committed to a dietary strategy that requires technology to execute. No fire, no food worth eating, no cooking, no survival. The cooking ape, the only animal in the history of life on Earth that genuinely cannot feed itself without a tool. Then there are the social and cultural consequences of cooking, which are almost as significant as the biological ones, and are considerably more interesting to think about. Cooking creates a meal, a shared, prepared thing, produced at a specific time and place, consumed communally. This is not a trivial social innovation. When your food must be cooked, you gather somewhere to cook it. You need fire, which takes effort to maintain. You need people to guard it, to tend it, to protect whatever is being prepared from others who might steal it. You need some organizing principle for who contributes what and who receives what in return. The campfire, in Wrangham's telling, is not just a cooking surface. It is the origin of the household, the most fundamental unit of human social organization. It is the place where a pair bond becomes useful, where having a reliable partner who will protect your cooked food while you're away gathering more raw ingredients and who will share the cooked output with you and your children confers real fitness advantages over being a solitary raw food forager competing with everyone around you. This is where Wrangham makes his most provocative claim, that cooking may be the origin of the sexual division of labor and of human pair bonding itself. Not romantic love as a cultural construction, but the practical arrangement in which two individuals coordinate their resource acquisition and share food, anchored to a hearth, with reproductively invested children as the context. The household organized around a cooking fire is, in this account, the seed from which the most fundamental human social institution grew. And then consider what happens when people gather around a fire in the evening, with their caloric needs adequately met from the cooked meal, with predators kept at distance by the flame, with hours of non-chewing time available before sleep. Language flourishes in this context. Storytelling becomes possible and useful, transmitting information about where food was found, what dangers were encountered, which social relationships need maintenance. Laughter, music, planning, the rehearsal of future strategies, all of these become possible when you're not spending every waking moment either chewing or foraging for more raw food to chew. The cooking fire did not just feed the brain, it created the conditions in which the brain could start doing the things that eventually made us recognizably human. Thinking about the past, planning for the future, transmitting accumulated knowledge across generations. The next time you stand in a kitchen and turn on a burner, or light a grill, or stand over a stove watching something come to a simmer, take 1 second to understand the full weight of what you're doing. You are participating in the oldest, most consequential, and most singularly human technology in the entire history of our species. Older than agriculture by at least 1 million years, older than any written language by far, older than any religion, city, civilization, or government. Older, arguably, than language itself. You are doing something that your ancestors were doing around modest fires on the African savanna more than 1 million years ago, and it is something that rewired the trajectory of the primate lineage completely. It shrank your jaw, shortened your gut, freed your time, protected your nights, organized your social world, and liberated enough biological energy to build and sustain the brain that you are using right now to read and understand these words. Every meal you cook is, in the deepest possible sense, a continuation of the act that made you human in the first place, which is a genuinely profound thought, even when you're doing it at 11 p.m. with questionable leftovers, standing in your kitchen in the dark, realizing the pasta is stuck to the bottom of the pan. The principle stands.